The James Webb Space Telescope, humanity's most cutting-edge device for exploring the cosmos, has delivered yet another monumental revelation: exclusive images of Pluto that are altering everything we thought we knew about this icy planet. The brand new information reveals astonishing, baffling secrets that are overturning the notion of Pluto being a lifeless, frozen rock at the edge of our solar system. It is now evident that Pluto is significantly more complex and dynamic than we ever imagined, with signs of concealed oceans, geological processes, and intricate, challenging chemical patterns. These discoveries have left scientists both amazed and deeply perplexed. At the center of this transformation is Sputnik Planitia, the famous heart-shaped region on Pluto's surface. What once appeared to be an enormous region of frozen nitrogen ice is now thought to conceal a sizable ocean submerged in liquid form and protected by a thick ice layer. This ocean may be one of the most important findings in the ongoing search for extraterrestrial life, with conditions insulated from the harshness of space, offering the possibility that microbial life could emerge within these dark recesses. The surface of Pluto itself remains full of mysteries. Towering ice mountains rise to heights comparable to Earth's tallest peaks, while vast plains exhibit an eerily smooth surface that suggests recent geological activity, levels of dynamic movement entirely unanticipated for a body once assumed to be frozen in time. Heat from convection occurs inside Pluto, beneath its icy shell, causing nitrogen ice to move slowly, almost like lava in a lamp. The world described in these revelations is far from static. Pluto is alive with ongoing processes. Despite its distance from the Sun, Pluto now joins a growing list of icy planets and moons, like Europa and Enceladus, that may harbor life beneath their frozen exteriors. Water and organic molecules could interact in ways that encourage conditions necessary for life to thrive, even if the organisms are microscopic. Discovering bacteria that can live on Pluto would significantly alter our understanding of habitability across the universe, proving that life can exist in places previously thought uninhabitable. What makes the relationship between Pluto and its moon Charon particularly intriguing is how it stands out from everything else in the solar system. Nearly equal in size, the two celestial bodies gravitate toward one another, with forces acting in concert to produce internal heat and drive dynamic changes on both worlds. Charon itself holds many mysteries, with its deep canyons and peculiar reddish hue suggesting a shared history with Pluto. It is possible that material from Pluto transfers to Charon's surface, hinting at an exchange of chemicals that could possess the fundamental components for life. None of these amazing discoveries would have been possible without the James Webb Space Telescope. Its infrared instrumentation allowed researchers to look beneath Pluto's icy crust, revealing hidden details that previous missions couldn't detect. By analyzing Pluto's surface and atmosphere, the telescope discovered organic substances and temperature variations, painting a picture of a world far more complex than we previously believed. Despite its thinness, Pluto's atmosphere is unexpectedly complicated, mainly composed of nitrogen, with traces of methane and carbon dioxide. This composition creates layers of haze extending hundreds of miles above the surface. As Pluto journeys along its elliptical orbit, its atmosphere undergoes dramatic shifts. When Pluto is closer to the Sun, surface ice sublimates into gas, forming a temporary atmosphere. As it moves farther away, the atmosphere freezes and falls back to the surface, a one-of-a-kind cycle not observed anywhere else in our solar system. These atmospheric dynamics offer scientists a rare opportunity to study how distant celestial bodies adapt to extreme environments. Among the most striking features of both Pluto and Charon are their reddish spots, likely caused by tholins, organic compounds formed when ultraviolet rays interact with atmospheric methane. Tholins not only color the landscape but also offer clues to prebiotic chemistry, potentially pointing to chemical processes that could be precursors to life. Researchers are particularly intrigued by how these compounds might interact with water ice beneath Pluto's surface. Could these tholins, when combined with other organic molecules, serve as the building blocks of life? It's an intriguing question that scientists are eager to investigate further. One of the most groundbreaking revelations about Pluto involves the possible existence of a vast ocean beneath its icy crust, kept liquid by heat from radioactive decay within Pluto's core. This ocean could span much of the planet's interior. On Earth, similar environments, such as deep-sea hydrothermal vents, are teeming with life. If Pluto's hidden ocean harbors similar conditions, it could support microbial life or even more complex ecosystems. Shedding light on the mysteries of Pluto's crust could transform our understanding of where life might exist, suggesting that even the most unlikely locations can accommodate thriving life forms. The release of categorized data and images from the James Webb Space Telescope has initiated worldwide excitement and speculation. The public, governments, and scientists are captivated by the potential insights Pluto's secrets may reveal about the broader universe. For decades, Pluto was dismissed as a meaningless celestial body, but these revelations have proven just how little we truly know about our cosmic neighbors. As more information emerges, anticipation grows around the many questions still left unanswered. The findings the Webb telescope has made are only the beginning. Future missions, including landers and orbital probes, will delve deeper into Pluto's mysteries. These missions could provide definitive evidence of its ocean, and possibly confirm the existence of life beyond Earth. Some even propose sending robotic submarines into Pluto's undiscovered ocean, a remarkable engineering feat that would mark one of humanity's greatest achievements in space exploration. As technology advances, the dream of exploring Pluto up close is gradually becoming a reality, offering an unprecedented chance to increase our understanding of the universe. One of the most remarkable aspects of Pluto is how it remains geologically active despite being so far from the Sun. Pluto generates enough heat to drive convection within its icy crust and support a potential liquid ocean. This heat may be due to the radioactive decay within Pluto's core, releasing energy over billions of years. Combined with gravitational interactions with Charon, this heat could explain Pluto's ongoing geological processes and the endurance of its potential ocean. Although Pluto lacks a strong magnetic field, interactions between the solar wind and its surface generate unique magnetic. Pluto's transformation from a distant mystery to a scientific treasure trove signals a broader shift in how we perceive the outer reaches of our solar system. Once relegated to the sidelines as a mere dwarf planet, Pluto is now at the center of debates about planetary classification, astrobiology, and the mechanics of planetary systems beyond the traditional boundaries. The discoveries made so far not only challenge our assumptions about Pluto itself but also compel scientists to rethink the potential of other Kuiper belt objects. If Pluto, with its dynamic geology, complex atmosphere, and possible subsurface ocean, holds so many surprises, what might lie hidden on other icy worlds like Makemake, Haumea, or Eris? The James Webb Space Telescope has merely scratched the surface, literally and figuratively. In the coming decades, the scientific community anticipates a new era of exploration. Proposals for advanced missions are already in motion: nuclear-powered orbiters, cryogenic drills, and AI-guided landers capable of conducting long-term research on Pluto's surface and beneath. These missions could answer fundamental questions: how deep is Pluto's ocean? What is the composition of its seafloor? Are there active hydrothermal vents? And, perhaps most tantalizingly, is anything alive down there? Furthermore, Pluto's strange orbital behavior, including its inclination and resonance with Neptune, offers insight into the early formation of the solar system. Its location in the Kuiper belt, among thousands of icy remnants from the solar system's birth, positions it as a key to understanding how planets and moons evolved billions of years ago. For now, humanity watches in awe as each data transmission from the James Webb Space Telescope unfolds like a chapter in a storybook written across the stars. The line between science and imagination continues to blur, and our view of the cosmos grows richer, more complex, and more inspiring. Pluto's tale is no longer one of exile from the planetary family. It is a story of resilience, wonder, and the endless capacity of the universe to surprise us. Geology that moves and a mysterious atmosphere both hint at the possibility of hidden oceans and organic molecules. A distant dwarf planet poses a threat to our understanding of what worlds at the edge of the solar system could be. The James Webb Space Telescope's groundbreaking images and declassified data have transformed Pluto from being just a curiosity into the focus of our investigation. These revelations remind us that even the farthest reaches of our solar system are brimming with secrets, waiting to be uncovered. In the future, Pluto serves as a signal of possibility and hope. Its mysteries inspire emerging missions, new technologies, and profound questions concerning our place in the universe. Could Pluto harbor life? What other wonders might lie beneath its frozen surface? And what insights can it offer about the origins of our planet? The story of Pluto is far from over. With every new discovery, we are reminded that the universe is vast, enigmatic, and full of surprises, if we are willing to look. As humanity keeps pushing the limits of space exploration, Pluto's story serves as a reminder of the endless possibilities that lie ahead. Once regarded as merely a speck at the solar system's edge, largely forgotten by the public and scientific communities, Pluto has regained attention. Revolutionary findings from the James Webb Telescope have reignited global interest in Pluto, offering a glimpse into its potential to reshape our comprehension of the existence of life. Pluto's strange mysteries and the cosmos it resides in are far from fully unlocked. With every mission completed, Scientists grow increasingly persuaded that this faraway world may offer vital clues about how life might function in extreme, remote environments. As we continue to unveil more about Pluto, it could eventually lead to new perspectives on how life forms and thrives, even in habitable zones far from the Sun. Moreover, the discoveries made thus far have implications for future space investigations, from determining whether microbial life exists in Pluto's hidden oceans to gaining new insights into the composition of distant celestial bodies. These advances may reshape how we approach the search for extraterrestrial life, within our solar system and beyond. The prospect of sending robotic probes to Pluto's surface, as well as deeper investigations into its underground oceans, is more exciting than ever. These missions could provide direct answers to the intriguing question, could there be life there? Scientists have already begun considering the possibility of deploying a robotic submarine that could travel beneath Pluto's icy surface, an incredible leap forward in space exploration technology. This rekindled enthusiasm for Pluto isn't limited to the scientific community. The public's fascination is growing. Space exploration is increasingly fueled by brand new revelations, like those offered by the James Webb Telescope. Each new piece of information about Pluto inspires more questions and speculation. Could life exist where we once thought it was impossible? What do these findings tell us about the possibility of life on more distant worlds? This surge of enthusiasm is also prompting broader discussions about the future of space exploration. With more nations and private companies entering the field, the competition to uncover the universe's secrets is accelerating. New tools and technologies are being developed to enhance our understanding of the solar system, with Pluto acting as a focal point for much of this innovation. If these advances continue, we might see a future where traveling to and studying distant worlds becomes attainable, turning what once seemed like science fiction into reality, opening up new frontiers for humankind. Another fascinating aspect of the James Webb Telescope's findings is how they are reshaping our ideas of habitability. Traditionally, the concept of habitability has centered around the Goldilocks zone, the region around a star where temperatures are just right for liquid water. However, Pluto's hidden ocean challenges that view. Could it be that life can exist in places we previously considered too extreme for survival? This possibility not only opens up new perspectives for understanding Pluto, but also expands our interest to other icy bodies beyond the solar system. Future research may reveal that the key to finding life in the universe doesn't rely solely on proximity to a star, but on the existence of chemical and liquid water processes that support life. Pluto is no longer just a faint speck on the outermost edges of our solar system. It has become a symbol of the endless potential for exploration. As the Webb telescope continues to reveal more about this distant world, it is inspiring a new era of curiosity, wonder, and hope. What began as a search for answers about Pluto's strange features has evolved into a broader effort to comprehend the profound implications of life, the universe, and everything in between. The mission to Pluto has only just begun. What started with a distant probe has now transformed into an international effort to piece together the puzzle of our cosmic neighborhood. Each discovery adds a new dimension to our understanding of the universe. Continued research into Pluto and other icy bodies in the outer solar system will likely lead to even more amazing revelations. The next chapter of space exploration is unfolding before our eyes, and Pluto will remain at the forefront of this new era. As we seek answers to the universe's most puzzling questions, Pluto serves as a timeless reminder of how much more there is to learn. With all its vastness and complexity, the universe still holds many unanswered questions, awaiting discovery. If only we continue to explore. What aspects of Pluto most excite you? Do you think we're on the verge of understanding more about life's potential beyond Earth? Feel free to share your thoughts below, and keep an eye out for more groundbreaking stories from the world of space exploration. As interest in Pluto continues to surge, its symbolic significance grows, not just as a target for scientific inquiry, but as a representation of the human spirit's relentless pursuit of the unknown. The same curiosity that led us to cross oceans, scale mountains, and explore the deepest parts of Earth now drives us toward the farthest edges of space. Pluto, once demoted from its planetary status and cast aside, has risen as a beacon reminding us that no discovery is ever truly complete, and that wonder often lies in what we overlook. What's especially compelling is how Pluto challenges our assumptions. The presence of a subsurface ocean beneath its icy crust forces scientists to rethink the conditions necessary for life. No longer can habitability be confined to sunlit, temperate zones. Instead, we're beginning to understand that warmth and energy might come from internal geological processes, such as tidal flexing or radioactive decay, making even the coldest worlds potential cradles of life. This realization is transforming how we approach exploration. Instruments are being re-engineered to withstand harsher environments. Mission plans are being redrawn to prioritize icy bodies, like Europa, Enceladus, Triton, and now, Pluto. These frozen moons and dwarf planets may hold more than just geological interest. They could hold the key to answering the age-old question, are we alone? And it's not just about finding life, it's about understanding the full spectrum of life's potential. What if Pluto harbors microorganisms that developed entirely independently from Earth's biosphere? What if it contains organic compounds that are precursors to life, shaped by processes we've never before witnessed? Answering these questions could reshape biology, redefine chemistry, and force us to reevaluate our place in the cosmos. In classrooms around the world, students now look at Pluto not as a forgotten celestial body, but as a place of real possibility. Future generations of scientists, engineers, and dreamers may one day walk in the footsteps of the missions we launch today, journeying deeper, reaching farther, and uncovering truths we can barely imagine. So, what lies ahead? NASA and international agencies are already discussing next-gen missions to Pluto, some involving orbiters, others potentially including landers or cryobots capable of drilling through ice to reach subsurface oceans. These aren't the dreams of science fiction anymore. They're becoming scientific goals, slowly, surely, and ambitiously. The success of these missions will depend on global cooperation, funding, technological innovation, and public support. But if history is any guide, humanity is capable of incredible feats when our eyes are set on the stars. As we continue to listen for signals from the void, study alien worlds, and reach beyond the limits of what we know, Pluto remains a symbol of what's possible when we dare to look further.